please welcome to the stage Aaron Schlesinger.
Hey guys, everybody hear me okay in the back? Yeah? Great. As he said, my name is Aaron Schlesinger. I'm a senior engineer at Deis. Come down to our booth, get some free socks. We'd love to see you. I will be down there after this talk, actually. I also sit on the leadership board of the service catalog SIG, so drop in there if you're ever interested in what we're doing. So today, as mentioned, I think in the program, this is a deep dive. We're going to actually go look at some code before we show a demo. Before all that, we're going to go through some use cases, including some stuff that we do at Deis with the Go client library. And then we're going to wrap up with some patterns, and if there's some time left over, I will run out into the audience and take questions from people on the mic, hopefully. So first of all, why would you ever use the Go client library, ever? Like, why not just script kubectl with bash or just manually do stuff at your computer? Why not just do that? Well, to get there, let's talk about how I or any one of you guys probably started with Kubernetes. I call it the 12 days of Kubernetes. I came up with that at about 2 a.m. this morning in my hotel room. You would probably start something like this, right? You would start with something I've called like the Zen of Kubernetes. That's something like learning why Kubernetes, learning about immutable deployments, learning about pods, learning about other basic resource types, services, deployments, replica sets, so on and so forth. Obviously, learning how to use kubectl. That's pretty important, right? You might even go a step higher and learn about Helm or some higher level tools like Helm. I have a soft spot in my heart for Helm because that was started at Deis. But there are plenty of other high level tools for Kubernetes. Then on what I've called the 13th day, not bad luck, this is actually a really good day for you in Kubernetes, you're probably going to go start automating a few things, right? So probably the primary thing is going to be CI. How do you get someone's code on a development team through a CI pipeline, through all the tests, stress tests, staging, all that good stuff, into an image? You probably have figured that out by now, by the 13th day. And then how do you get that image onto a cluster? Maybe you're going to go to a staging cluster first, or a pre-prod cluster, I've heard it called sometimes. And then you're going to promote to real production, to the big show, right? How do you go through that process? Well, first step might be to start scripting kubectl. Write a bash script or write it in Groovy in Jenkins or something like that. And then you're going to do a couple kubectl commands to move through this process, right? You also might start scripting some things like backup. Run a script to do some kubectl stuff inside of a pod and put that in a cron job, for example. And start doing some backup or analytics on your cluster or troubleshooting, or maybe email out a report to your team on how your cluster's doing. We're going to talk about the 14th day here today. This is when you start leveling up in your automation, and you've got to do stuff that maybe bash or just kubectl or something at that level is not really going to be enough. And you have to start talking directly to Kubernetes, directly to the Kubernetes core API, and doing things like watching the event stream and reacting to events in a meaningful, really deep way, right? That's just one example, and that happens to be something we're going to demo today, and we're going to see some code for today. And there's plenty of other examples out there, right? So here are some examples. Who here has heard of a third-party resource in Kubernetes? Wow, awesome. We're going to touch on Kubernetes third-party resources today in the demo. I'm really, really happy to see everyone raise their hands here today. I love TPRs. I call them TPRs. I think they're called 3PRs by some people, too, or whatever other abbreviations. Who here has heard of ingress controllers? That's amazing, too. Thank you. You guys are a great crowd. Thank you very much. Give yourselves a round of applause. Anybody? Yeah? Okay. Awesome. Awesome. We heard yesterday from the Philips keynote at the end of yesterday. They wrote their own horizontal pod autoscaler. One of the easiest ways to get there is to use the Go client library. Writing your horizontal pod autoscaler in Go is probably one of the lowest friction ways to get something meaningful done. You could probably script something. There might even be a bash Kubernetes client out there, and if there is, come find me later. We'll have a discussion. I'd love to see that. But the Go client library is sort of made for tasks like this. And then that last one there, user aggregated services or user aggregated APIs. This is an up-and-coming technology. We're actually using it in Service Catalog right now. And this is a way to extend the Kubernetes API without touching the Kubernetes core codebase at all. Right? You can build your own API, and starting in 1.6, I believe it's in alpha support now, Kubernetes will figure out how to route traffic from the Kubernetes core API to your API. But your API, here's the catch, it has to look like Kubernetes' API. It has to be kubectl compatible. It has to have resources. It has to have auth. You're not going to probably be able to write that in bash, right? I'm bashing bash a lot. I actually love bash. But you're probably not going to write it in bash, and that's probably not a good fit in this case. You might be able to write it in some other languages too, and there are some up-and-coming libraries to do that. But the Go client library, as of now, is probably the best fit. And then let's go to some things that Deis and others have done. We have Deis Workflow. That's an open source project where we've started maybe almost 2 years ago now. And it's a PaaS. It's a platform as a service that runs on top of Kubernetes. There are a bunch of pods. I believe we have 12 projects under the workflow umbrella. They run a bunch of pods inside of Kubernetes, and they do almost everything under the sun you could think of to the Kubernetes API to make Kubernetes look like something like Heroku, right? So you can git push to this thing, and it will go and build your code with a slug builder, or if you push something with a Docker file, it'll do a Docker build on it. It'll do that in a different pod, and then it'll figure out when that pod's done, and it'll create an image for you, and it will push that image to a registry of your choosing. It can be inside the cluster, or it can be Docker Hub, or Quay.io, or GCR, or anything else, right? And then after that's done, then it will somehow, magically, it will push that, and it'll get it into Kubernetes, right? It'll trigger a deployment, or it'll use a replication controller in the old school version. Or it might launch a job, background job. Many other possibilities there. And then if it's network routable, it'll create a service. And then the router component, the thing called the router mesh, will figure out that that new service exists using the watch stream. And then there's a logging component. And then there's monitoring. And then there's this. And then there's that. And if you build a PaaS inside of your company, if you're on the SRE team or the DevOps team or the dev team that's in charge of the PaaS, you're going to add feature A, and then you're going to have feature B, and then this new team is going to come along and start using your Kubernetes PaaS, feature C, then D. And this is a really great problem to have, right? I'll hit the wall soon. You're going to have all these features that people want because Kubernetes is so great for deploying apps. And your PaaS is going to be the way to build it, right? Your developers are going to want more and more features. In the Go client library, I can stand up here and almost guarantee that's going to be the fastest way to get these features out the door for your developers. And then we have wizard level. These are some things we've done at Deis that have turned out to be really fancy. In some cases, they've been overkill. But we've got things like distributed coordination, right? This is a primitive, a distributed lock or distributed lease that's waiting for something else to complete and putting that in a critical section so that nobody else can touch it. We've got leader election. Anybody heard of leader election? Cool, cool. That's having a process do all the work and having a bunch of other processes wait. And if that main process fails, one of those other guys will pick up the slack and they'll start doing the work, but only one of them is going to do the work at a single time. Distributed latch. That's, again, sort of like coordination. That's waiting for someone else to finish work elsewhere in the cluster, and then you continue your work. Okay? Just some of the use cases for going in and starting to look at the client Go library, the Go SDK. Let's go into code mode now. Let's start talking about what this really looks like. Okay? First of all, what is the SDK? It's a Go package. You can go get it or use your favorite Go dependency manager. It's there. It's called kas.io/clientgo. It is focused, as the name might imply, on building clients. It's outside of the mono-repo. It's outside of Kubernetes/Kubernetes. It's specific to clients, right? You get full access to the core Kubernetes API. That's everything. All the resources, watching, all the event streams, everything. And you're going to get the best bang for your buck starting there, starting access to the core API instead of using kubectl to do it. I think there was kubectl was another name. I'll use kubectl today. But there's also more, right? There's higher level constructs I'm not going to be able to show today, but there's higher level constructs to build really rich controllers or to do really fancy caching on the client side. And I encourage you, that's kind of wizard level 2, is that you start using the client library, and then you want to go build something even more high level, go look at those packages too. And they're all inside of this package, Client Go. So let's talk about some of the relevant packages in Client Go. Okay? These are the ones we're going to see today. There's tons more. So first of all, starting from the top, Kubernetes is the first sub-package that you'll hit when you use Client Go. So the Kubernetes package basically contains this big old thing, this big old struct in Go, and that will give you access to everything, the whole gamut of resources in Kubernetes. You can get access to the core API groups, extensions, so on and so forth. And then there's REST, the second one down. That contains a raw REST client. You can literally talk to Kubernetes using get this path or HTTP post this path with a body. And it also contains config, and you'll use it most for config. And that's just how do I locate, authenticate, and authorize with the Kubernetes core API server. And then there's Dynamic. Now, Dynamic is sort of a smaller client that sits inside of the Kubernetes master client. And that we're going to use today to talk with third-party resources. I told you I'd come back to third-party resources. We're going to come back with a vengeance in a second. And then that last one, PKG API. That ... means there's a whole bunch of stuff under PKG API. That's where you will find all of the resources that you know of in Kubernetes. There is a Go struct for pods, services, namespaces, deployments, nodes, everything. They're all accessible there, and they're all Go structs, so you can work with them in memory as you go. Now, PKG API also has some smaller data types that you'll use if you start working with things like third-party resources. So you will compose some of these data types into your own structs in order to make Kubernetes compatible things. And we'll see that as well in the code. Okay, so we always start with something like hello world, right? Now this is sort of the simplest thing to show off some of the concepts that we can put on paper, on e-paper. Right? So that first line there is a really handy convenience function. And what that is give me a configuration for talking to the Kubernetes core API, just given all the stuff that any pod in the Kubernetes cluster will already have. So Kubernetes will inject all pods, almost all pods at least, with a file with the service account in it, and a couple environment variables that hold the location of the Kubernetes core API. That is one of the most convenient things I've ever seen in the Go client library, or the mono-repo. You call one thing, you don't have to know where any of this information is, and it'll just give you back a config, or an error. And that you'll find that error a lot of times if you accidentally run your program outside of Kubernetes. And there are some ways around that that I can get to after if you come find me. Then that second line, given a configuration that I got in the first line, create that new massive client, right? Create me a client, given that configuration, that I can use to do everything if I want to. And then that third line, that's basically just list all the pods in a given namespace, right? That can be pretty handy. You can also list all the pods in all namespaces. We'll see that in use in the code as well. But there are tons and tons of other uses here, right? You can call core v1, that first function on CL, and that'll give you access to all the core Kubernetes resources, pods, services. Again, the list goes on and on. You can call extensions, and extensions will give you access to all of the things in the API group called extensions, and so on and so forth. But that's just hello world. So let's talk about something real, more real, something you might actually use. Let's talk about a program that can back up the state of a cluster, right? Let's talk about something where I can tell it to back up pods. And when I tell it that, it's going to grab all the pods, just as we saw on the previous slide, that third line. But it's going to grab all the pods in all the namespaces, and it's going to back them up somewhere so that I can see over time, what did my cluster look like? What pods were running? Right? That could be pretty useful. But furthermore, I want to make this thing a little simple. Right? I don't want to have to open up a port and serve on a REST API and create a client for that REST API. I want to just kubectl create -f, a third-party resource, just like I create anything else in Kubernetes. And I want that to trigger the backup processing. So that's the context. Let's talk about how this thing will look before we go into the code. I promise, last slide before code. Who here was waiting for code and saying, shut up, let's get to the code? Okay, fair enough. We'll get there. I want to show this before we get into the code so you guys know kind of what's going on. So first of all, our main function. Every Go program starts with a main, right? A lot of other programming languages do that too. Now that's the thing that's going to create a watcher, the thing that consumes the watch events. It's going to use the dynamic client to do that. It's going to send every watch event down into the watch event filterer. That's just going to decode stuff into those backup third-party resources that I'll show. The filterer is going to send those decoded events back up into the watch loop, and the watch loop is just going to multiplex. It's going to figure out what resources did the user ask me to back up. Once it figures that out, it's going to send a function call to this thing called a fetcher logger. So based on if you say, I want to back up pods, it's going to go and say, hey, fetcher logger, go back up the pods and log them out to standard out. Of course, in a more advanced version of this program, let's say, you might, instead of log to standard out, you might put them into a file and send them up to S3, something along those lines. All right, told you, let's go to the code. Alrighty, make this a little bigger. Can anybody not see this? How about now? We'll make it a little bigger. Good? Are those thumbs up or make it bigger? Okay, good. All right. So here's our main. This is where it all starts. You guys probably know that. Here's that pattern again. In cluster config. This thing's going to work in pods without me having to figure out what environment variable is here, what file is there. Same thing. Let's create that big master client from the config. Now we get a little fancy. From that same config, let's create a dynamic client. This is the thing that we're going to use to talk to third-party resources. Okay? Next line we care about. Let's create the watcher. That was the box on the left, the bottom left-hand side. Right? The watcher is going to be that thing that watches these third-party resources. Next, let's run that loop. That's the loop that's going to consume those watch events. It's going to wait for an event to come in. It's going to multiplex to the right fetcher logger, and then it's going to call that fetcher logger to do the work, the real work that we care about. Okay? Next, the third-party resource itself. This backup object struct in Go language, this is the thing that we're going to decode from the watch stream into, right? Those first two lines, unversion.type meta and API.object meta, that we'll call it boilerplate, right? You probably have seen the pod struct or the namespace struct. All of the in-memory Kubernetes object types have these two lines in them. And they're very convenient. And if you try to write a Kubernetes resource type in a third-party resource, for example, without those, you're going to have a hard time. So I recommend first two lines, always put those. And then the thing that we care about today is resource type. That's the parameter that's going to tell our watch loop, what do I want to back up? It's just like calling a function and saying, these are the resource types I want to back up. Next, the watch loop itself, the watcher itself. We create a watcher right here from the dynamic client that I showed we created in the main. Okay? So we're watching backups, the backup resource type, in a given namespace. And then down here, we're going to send all those watch events through a filterer. Okay? Let's go down to the filterer. This is a big decode and encode job, right? We get objects coming in as this unstructured type. That's a bucket of bytes. Kubernetes says, I've never heard of a backup. I'm just going to dump you some bytes, and you figure out what to do with it. And we will figure out what to do with it on the next line, okay? So we're going to marshal and then unmarshal into our backup object that I just showed before, okay? Once we do that, assuming all went well, we're going to return a new watch event that looks pretty similar to the old watch event, except this new thing is going to have a backup in it. And that's the thing that we know how to deal with in our watch loop. Speaking of, here is the watch loop. Lots of code in here. Let's focus on two things. First thing here, we're going to consume from a Go channel that represents these watch events coming in, right? These are in-memory watch events that we're going to figure out what to do with. Second thing, up here on line 18, this is an infinite for loop. That is not a bug, okay? This watch event on line 26 can close at any time. This is a channel that if the server decides no more watch events for you, it'll sever the connection, and we'll figure out that the connection is severed by that channel closing. And if that channel closes, we're going to bail out of this inner for loop, we're going to log, and then guess what? We're going to go back up to line 18 and start all over again, okay? And then finally, there's a switch statement here. We're only going to support pods in this demo. I'll get to in just a second. But you add more cases there, your watch loop thing can start supporting all kinds of other resources. And then finally, here is the fetcher logger for pods. Remember this? Whoops. Remember that? The only difference between that and what we showed in our Hello World example is this is grabbing pods from every single namespace. That's what that open parentheses, close parentheses means. You can do that. That's valid in Kubernetes. Not recommended in lots of clusters because when you get to, let's say, 100 pods, that's going to take forever. Lots of data is going to go over the wire if you ask for a bunch of pods. So I wouldn't recommend doing that in a production cluster. Instead, I would probably iterate through namespaces and do it one namespace after another. All right, let's see this thing in action. Put your hands together, pray for the demo gods. In this case, if this doesn't work, it's 100% my fault. All right, so you can follow along with the code here at this GitHub address. Everything's open source. Everything's git push to master from my computer. And the first thing I'm going to do is I'm going to install this watcher. I'm pretty sure no one can see this, so let's do this. Anyone cannot see this? Thumbs up all around? Great. All right. We're going to install the watcher. It's going to download this from quay.io. We're good. Thanks, Wi-Fi. We're going to look at logs. Remember, when we get a backup third-party resource coming in, we're going to fetch all the pods and print the standard out. So when we create that backup third-party resource, we're going to see a big, huge chunk of JSON that represents all the pods in our cluster. And we're going to see it there. Just to make sure we can see it, let's do that. Okay? Second step. Let's install a backup. Before we do that, I want to show you what a backup looks like. Okay? This is probably familiar. I want to point out one thing that's different from this and a Kubernetes built-in resource. That. Has Kubernetes ever heard of a backup resource? Have any of you guys heard of a backup resource in the Kubernetes core? Okay. That's good, believe it or not. And the reason is because in the watcher, I created a third-party resource called backup. So after this was submitted in that helm install command that I just ran, now Kubernetes knows what a backup is. So when I do the second helm install, I will now be creating a thing that Kubernetes knows what to do with. Okay? When we create this, I'll go back to the first tab in my terminal, and we're going to see it picks up the backup, and it prints out all the pods. Here's where the rubber should meet the road. All right. We got pods 0 through 4. Let's make sure this thing actually worked. Let's get all the pods ourselves. And there you have it. There's 5 pods, pods 0 through 4. Now this is the pod here that we actually care about. But the purpose of this thing was to dump all the pods. And again, as I mentioned before, you might want to extend this thing and maybe dump it to persistent storage, put it in S3, maybe send an email out with a report. And also, it's not that useful to print out pods, right? You might want to print out all the services or the network ingress policies or the namespaces or something like that. You just go in and you add a case statement to that code that I showed you, and now you've got access to those two. And you just pass in a backup TPR with the resource type called namespace, if you had namespace support, or service, if you had service support, and so on and so forth. Okay? So let's do a little recap on what we just wrote. We've got some patterns out of this, okay? So what we built in Kubernetes land, you're probably familiar with this name, is called a controller or a controller manager. This is a thing that generally doesn't really have a meaningful network interface. You don't really call, like, get something on a controller. It's watching. It's watching for events. The Kubernetes has some built-in controllers that watch for events on the core API server, and then they reconcile state. We did the same thing. We watched events on the Kubernetes core API server for those backup TPRs, and our reconciling of state was we just did another call on the core API to get pods, and then we printed it out, reconciled, right? Also, remember those 2 for loops? We were prepared with that outside for loop that went on forever. We were prepared for the watch stream to close at any time. Now, there's another way you can do that. You can just crash. And if you crash and you're running inside of a deployment, replica set, replication controller, what have you, Kubernetes will just restart you. We built our own resource. We built a TPR called backup. I showed you the template for that. That's a great way. I think I mentioned this before, too. It's a great way to super easily extend Kubernetes. I'd recommend looking into that if you want to add some custom functionality before you go and look inside of Kubernetes proper and submit a pull request or file an issue or anything like that. These can go a very long way. Okay? Forgot my little clicker. So with that, I want to say thanks. We've got 7 minutes and 27 seconds left for questions. So I'm actually going to run around the room. If anyone has questions, raise your hand. All right, go with you. I'm going to run to you with this little fancy thing and have you say your question into the microphone. If I can get it off of my head. I could do that, but this is more fun.
Okay, cheers, thank you. So my question is to you and to the audience is, okay, controllers are great things for asynchronously processing events, but what if you want to be inline? So for example, you want to prevent a pod spinning up for whatever conditions you want to have, or custom authorization or whatever thing you want to be inline, not asynchronous. Thank you.
Yeah, so that's a great question. So the question was, I'm going to summarize. What if you don't want to have a controller running in the background? What if you want to do something such that, let's say you kubectl do thing, and it should fail, just right then and there, not have to go and wait for the controller to do some work, and then have someone look in the controller's status field. My summarization was longer than your question, so sorry about that. So what you're going to have to do there is look into the user aggregated service thing. You can Google it. User aggregated services just came out in 1.6. And again, just to recap what those things are, Kubernetes core, the core API server, will route traffic to your API server, right? Your API server then can do the action to intercept a request, fail the request if necessary, and that gives that feedback back to kubectl. Writing a UAS, your user aggregated service, that's probably another talk. And once it's stable, to be honest, I'll probably submit a CFP for that, and we can talk about that next time. So, still in alpha, so probably worth reading, but probably not worth putting in production yet. So, other questions? Okay, shout it out.
You're super ramming on for loop. Should you just fail fast? Here's the thing. My
The question was, shouldn't you just fail fast? If the watch stream, in our case, if the watch stream is broken, why not just fail fast and let Kubernetes restart it, assuming you're running inside of a replication controller or a replica set? Stellar question, and yes, you could fail fast. That's totally valid. The problem in both cases, actually, in my code and the fail fast case, is that you'll miss watch events, right? Either way. If the watch stream gets broken, you'll miss like a couple hundred milliseconds probably of watch events. If you fail fast, it's more up to Kubernetes how many watch events you'll miss. And the solution in either case is that you have to relist the resource that you're looking for. And that's where we get into the controller infrastructure that lives inside of Client Go. So what the controller infrastructure does is that double for loop, just to make it a tiny little bit more robust and not have controllers continuously failing. But they periodically relist. So they'll relist backups in our case. And when the relist happens, they then reconcile again. And they reconcile based on what backups haven't been processed yet. So failing fast is a great place to start. Once you go into the controller infrastructure, they'll take care of the double for loop stuff for you. So that seems to be the de facto standard, is to kind of build a little bit more resilience into the app. But I would actually recommend failing fast to start. So yes. Yep, Ron, just shout it out.
Is there a way to select portions of the response? Like, when you're trying to get a pod in, you get sort of a dump of each JSON file. Can I select only portions of what I want to return?
Yep.
Especially when you want to query.
Sure. Yeah, so the question was, is there a way to select portions of a response? So for example, if you're listing pods, instead of having a big, huge, massive response body, can I drill into just a specific part of the pod spec or the pod status? And the answer is yes. So when you get pods back, you'll get back a list called a pod list, convenient name, right? And the pod list will have an items field in the struct, which will be a Go slice, which is another word for an array, of pod types. Right, and each pod type will have individual fields in the struct. And from those, you can just select one or more of the fields. Gotcha. Gotcha. So that's not as easy. To ask Kubernetes to just give a specific part, it will return the whole pod spec, the whole pod manifest actually to you. And that's where the paging comes in. Or if paging is too much for you, just selecting all the pods in a single namespace instead of all the namespaces. There's no support currently built into Client Go, unfortunately, to do sub-pod resources. We've got 2 minutes, so let's say one more question. Yeah?
So again, piggyback on that, two questions. One piggyback on that is the filter options when you list, for example, node selector or namespace selector, that's like a black art. I couldn't find that documented anyway.
Yeah.
Can we find that?
Yes.
Question number one. And question number two, for Client Go, generically, any pull request should go to Kubernetes or should we go to Client Go? I'm still confused about where that should go.
Sure.
Okay, thank you.
Yep. So the first question was, is there a way to do label selectors as one of the examples? There is. My slides are gone for some reason. I think my computer died. If you go to the GitHub repository or go to the slides, which I'll post, when it lists all the pods, there's a v1.listOptions at the end of that call. List options is where you can do label selectors, and there's a field selector as well. Field selectors are a start to getting sub-pod resource fields back. They don't go all the way down that road, but I imagine they will soon, probably in 1.7. Second question was, what do you want, or what if I want to update Client Go, submit a pull request on it or something like that? So Client Go currently, as it stands right now, gets copied from a staging directory inside of Kubernetes. So I would recommend starting with an issue or pull request on Kubernetes, and then waiting for the next release to get it copied over. If you're impatient like me, I would probably just go into Client Go itself, submit a pull request, and then have someone else figure out how to get it in faster. So that's the best I got for you right now. So that's all I have for now, for today. I really thank you guys for coming. Thanks for switching rooms with me. It's been great.